Next, we'll have to create the material and assign the material to the blank. So for that, let's go to the part module, go to the modules, go to the property module, sorry. So first we are going to create a material. So for that we go to the material manager, create. So this is aluminum killed steel. Now I'm going to do a static general analysis. So for this I don't really need the density. I only need to prescribe the elastic and plastic properties. Remember that we are choosing the units of newtons for force, seconds for time, and millimeters for length. So all properties will have to be assigned accordingly. Please note that in ABAQUS you only assign numbers and you don't explicitly state the units. Units are assumed. So let's go to mechanical, elasticity, elastic. We are assuming isotropic elastic behavior. So the Young's modulus is given as 200,000 MPa and Poisson's ratio is 0.3. For plasticity, let's go to mechanical, plasticity, plastic. This is the option you have to choose whenever you are dealing with classic plasticity modeling. The hardening behavior is taken to be isotropic. Now we don't readily have a Swift power law hardening model option in ABAQUS, so we have to give a tabular data for yield stress as a function of plastic strain. So for that, what I have done is I have created this list in Google Sheet. So I go to the sheet where I have created this. So first what I do is I create a list of plastic strain values with an increment of 0.002. So I say that a particular plastic strain is equal to the top value plus 0.002, and then I create a list up till plastic strain of 0.5, a little higher than 0.5. Then I say yield stress is equal to the strength coefficient 572.4 multiplied by the value of the plastic strain epsilon plus epsilon naught, which is 0.002, whole to the power of strain hardening exponent, which is 0.237. Once I evaluate that for all the values of plastic strain, I get this list. So what I have to do now is I have to copy this list, Control C, come here and paste it over here, Control V. Alright, so I have to create this stress versus strain, yield stress versus plastic strain list. Then I have to go to sub options, potential, in order to prescribe this stress ratios. Please remember that we have evaluated this already. So R11 was 1, R22 was 1.0256, R33 was 1.252, R12 was 1.0897, 13 and 23 are 1. Please note that for an isotropic material, the values of all the stress ratios will be 1. And for an orthotropic material, they deviate a little bit from 1. R11 is typically taken to be 1. Okay, so that's it. So for this particular problem, it's going to be a static general analysis. So quasi-static analysis, thermal effects are not there. So just prescribing elastic and plastic properties is suffice. Okay. So now the material has been created. We will create a section now. So for that, go to the section manager, create. So I am going to call this as aluminum killed steel section. So it's a solid homogeneous. Continue. Material is aluminum killed steel. Okay. Alright, so the material has been created. Now I have to assign that material to this blank. So for that I go to the section assignment manager, create. So I select the whole region, done. Assign this section, say OK. Once the section is assigned, the part turns green. So this is an indicator that you have assigned it. For anisotropic materials, you also have to prescribe the orthotropic directions. So for that, you go to the assign material orientation, select the whole region, done. And then we are saying use default orientation. So what it means is X corresponds to 1 direction, Y to 2 and Z to 3 direction. Okay, so I'm just going to select this. Okay, so now you can see that, okay, this is 1, this is 2, this is 3. Say okay. Alright, so this is done. So material prescription is done.